Let's take a look at systems of nonlinear equations. Nonlinear means equations that would be any other shape besides a straight line. So in this case, we're going to talk about circles or parabolas or something that is potentially curved. So let's take a look at two equations. For this example, let's look at the equation x squared plus y squared equals 8. And let's go ahead and call that equation 1. This equation would be one that is a circle. Our second equation is going to be x squared plus 2y equals 0. This is an example of a parabola. Let's talk about solving this system of equations. You have a choice to either use substitution or elimination. It doesn't matter which one you pick, do whatever is easiest for you. However, a couple words of advice. In this case, I have x squared terms in both of my equations, so if I was going to use elimination, it would be okay if I tried to eliminate my x squared terms. I would not want to try to eliminate my y terms, because in this equation I have a y squared, and in this one I have a 2y. There's not really a nice way for me to get those to be the same term with opposite signs so that I can eliminate them. I'm going to multiply my bottom equation by a -1, so I can use elimination. I'm going to keep my top equation the same. For my second equation, I'm going to get negative x squared minus 2y equals 0. Remember that I'm still multiplying my right-hand side of this equal sign by this -1, but anything times 0 is still going to give me 0 right back. Now I can go ahead and add my equations together. When we do that, we're going to get y squared minus 2y on the left and 8 on the right-hand side. Notice now that you have a quadratic. We want to get everything on one side, 0 on the other, and do yourself a favor and put things where your squared term is going to be positive. Since my y squared is already positive here on the left, I'm going to leave it here, so I'm going to move this 8 to my left-hand side. Now I'm in a situation where I can factor this. I can factor this into y minus 4 and y plus 2. And when I set each of those factors equal to 0, I'm going to end up with a y value of 4 and a y value of -2. Now, let's go back and figure out what our x values are. Again, you can go back to either one of these original equations, either equation 1 or equation 2. It is your choice. I'm going to go ahead and use equation number 2. I chose equation 2, which is x squared plus 2y equals 0, and I'm going to start with my y value of -2 and plug it into this equation so I can solve for x. When I plug it in and simplify, I end up with x squared minus 4 equals 0. I want to solve this equation for x, so I'm going to go ahead and add 4 to both sides. When I do that, I end up with x squared equals 4, and then I can go ahead and take the square root of both sides, and I'm going to end up with an x value of both positive and -2. Let's go ahead and write the two solutions that we have so far. So far we have two solutions. If I work with my x value of positive 2, remember that our y value was -2. So my first point is 2, -2. I also had an x value of -2 here. That's that x value of -2. And my y value is still -2 for that point. So far I have 2 points. Let's go ahead and check our other y value that we got. Remember that we also had a y value of positive 4 when we first solved that system of equations. I'm also going to be checking that in my equation number 2 so that I can solve it for x. When I plug in my value of 4, I end up with an equation that says x squared plus 8 equals 0. When I subtract 8 from both sides, I get x squared equals negative 8. This is not an equation that I can solve in order to get real solutions. If I take the square root of negative 8, I'm going to end up with some imaginary answers. So this one produces no real solutions. The only points I would have of intersection would be these 2 points that I found earlier. If you use your graphing calculator or Desmos to go ahead and graph these equations, you would notice that they only have 2 intersection points, and these would be the 2 points that we found. This left-hand point of intersection would have been your point -2, -2, and over here would have been the point 2, -2.